Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we'll work on max consecutive ones, 3. So the problem states that we are allowed to flip at most k zeros, and our goal is to find the longest subarray containing only ones after flips. First, we'll quickly look at the brute force approach, and then we will move to the optimal sliding window approach that runs in linear time. So the idea is we will try every subarray, count how many zeros it has, and if zeros is less than or equals to k, we will update the maximum length. So let's initialize a variable n with the length of the given array and a max length variable initially 0. Now for each I, now that we need subarrays, j starts from I and j less than n, j plus plus, and now we will check if the current element, which is nums of j, is 0. If yes, then let's take a variable zeros, initially 0, and if it is 0, then we will increment the count of zeros. Otherwise, if the zeros is greater than k, then we can simply break. Otherwise, we will update the maximum length to max length and the current length, which is j minus I plus 1. And at the end, we would return max length. Let's run the code. It is working. So here we are trying every subarray and counting how many zeros it has. So if the zeros is less than or equals to k, then only we will update the maximum length, otherwise we would break. So why this is not ideal? First thing, we are using nested loops, so the time complexity will lead to O of n square. This will lead to time limit exceeded for larger inputs. So now we need to come up with an approach where the code runs linear. So here the key observation is we want the longest window where the number of zeros is less than or equals to k. So with the sliding window strategy, we can expand the right and we would count zeros. So whenever the zeros is greater than k, just like how we break, we would be shrinking the left. Otherwise, we will be tracking the maximum window size. For that, we need a variable left. Okay, let me comment this too, and this too. Okay, so we need a variable left, initially 0, and we need zeros. Zero count is initially 0, and we need a variable max length to track it. And now for int right starts from 0 and right is less than nums dot length right plus plus. Okay, whenever the current element, which is nums of right, is 0, then we would increment 0 count. Otherwise, while 0 count is greater than k, we would shrink the left But before shrinking, we will check if the current element nums of left is 0, then we would decrement 0 count. Okay, and then we would increment left. And after coming out of the while loop, we would update the maximum length with math.max of max length and the current length, which is right minus left plus 1. At the end, we would return max length. Let's run the code. Okay, let's submit it. Cool. So this code is working. The time complexity would be O of n because we are doing it in a single pass, and the space complexity would be linear O of 1 because we did not use any extra space. So yeah, so for example, in the sliding window approach, if you consider this example, the left starts here and the right also starts here. Since it is not 0, it will check if the 0 count, which is 0, is greater than k. No. So then it will move till the end, and here when it encountered zeros, since this count is greater than 2, then it will start shrinking the left window and it will calculate these 4 and the 2 flips, this 0 and this 0, so it would become 6. So it will be easy if you dry run this code. So yeah, in the next video we'll come up with another problem of maybe a different pattern. That's it for today's problem. See you in the next one.